Assalamualaikum. My name is ZIKRY. Welcome to this video summary on analog and digital modulation techniques. Moving to slide 1. What is modulation? Modulation is technique used in a communication system to transmit information over a long distances. It helps signal travel efficiently by modifying a carrier wave. There are two main types: analog modulation like AM and FM, and digital modulation like ASK and PSK. These techniques are essential for radio, TV, mobile networks, and satellites. Slide 2 is amplitude modulation, AM. So amplitude modulation, AM, is a method where the amplitude of a carrier wave changes based on the message signal. It is commonly used in AM radio and aviation communication. The modulator circuits include an oscillator, mix, and amplifier, while the demulator extracts the original signal using a diode and low-pass filter. 3. Amplitude modulation diagram. The slide shows how AM works using three graphs. The top graph is the message signal, which is the original sound or data, and the middle graph is the carrier wave, a high frequency sine wave. The bottom graph is the signal where the carrier wave's amplitude changes based on the message. The shape of the AM wave follows the message signal. The changes in amplitude represent the sound or data being sent. Slide 4. Divination is the process of recovering the original message from the AM signal. The demulator circuit removes the high frequency carrier wave and leaving behind the message. This is done using a diode and a low pass filter. AM demulation is widely used in radio receiver to play sound. The diagram here shows how the AM signal is processed. The top graph is the modulated signal before demulation, and the bottom graph is the recovered signal, which looks like the original signal from slide 3. Slide 5, frequency modulation, FM. So frequency modulation, it works by changing the frequency, which is the speed of wave oscillation, instead of amplitude. FM is used in FM radio, police radios, and telemetry because it has better noise resistance. The modulator circuit uses a voltage control oscillator (VCO), and the demulator uses a phase lock loop (VLL) to recover the signal. Moving to slide 6 is frequency modulation diagram. The diagram here consists of three graphs. The top graph shows the message signal, the original sound or data, and the middle graph is the carrier wave, a high frequency signal before modulation. The bottom graph is the FM signal, where the frequency changes according to the message signal. A higher message amplitude means a higher frequency, while the lower amplitude results in lower frequency. It's unlike AM, where the amplitude changes. This FM keeps the amplitude constant. This makes FM more resistant to noise, which is why it is used for high quality sound transmission. Moving to slide 7, which is frequency demodulation, FM diagram. So basically, FM demodulation is the process of extracting the original message from an FM signal. A PLL circuit or frequency discriminator is used to convert frequency variation back into sounds. FM demodulation is widely used in FM radio and communication devices. The diagram shows the process visually. The top graph is the modulated FM signal, where the frequency changes based on the original signal. And the bottom graph is the recovered message signal, the similar to the one in the slide 6. Moving to slide 8. So basically, amplitude shift keying ASK. Digital modulation (ASK) is a digital modulation technique where the amplitude of the carrier wave changes based on the binary data 1 and 0. So it is simple and use optical fiber communication and remote controls. The modulator uses a carrier generator, switch, and diode, while the demulator uses an envelope detector to extract the data. On the left side is the diagram. it shows how ASK works. The wave is represent height, amplitude, and for a binary one, and the absent low amplitude, the one that absent is the low amplitude for a binary zero. So this pattern allow digital data to be transmitted. Now moving along to slides 9, which is phase shift keying PSK. Digital modulation PSK is another digital modulation method that changes the phase of the carrier wave instead of amplitude of or frequency. It is commonly used in satellites, Wi-Fi, and RFID systems. The modulator shifts the wave uh, phase based on the data, and the modulator compares the received phase to decode the signal. The diagram here shows how the wave phase shift to represent binary data. It's unlike ASK, the amplitude stays the same, making PSK more resistant to noise. So basically, analog and digital modulation have different advantages. While the analog AM/FM is simple, but it uses more bandwidth and is affected by noise. Digital ASK/PSK is more efficient and resistant to noise, but it requires more complex circuits. The table here in this slide it compares key features. Analog modulation is used in radio and TV, while digital modulation is used in Wi-Fi, mobile networks, and satellites. Slide 11, which is the conclusion. So, in conclusion, analog modulation is easy to implement but can suffer from noise. Digital modulation provides better efficiency and quality, making it more suitable for modern communication. The choice depends on the system requirements such as data rate, noise levels, and complexity. This concludes the presentation. Thank you for listening.